Now let's look at radioactivity. It is as easy as alpha, beta, gamma. Let's start with the alpha decay. An alpha particle is a helium-42 nucleus. You do need to know this, so you can fill in these numbers and can balance this type of nuclear equations. Now see if you can balance this equation. For the alpha particle helium, we put 4, 2 right here. And since this is 238, that should equal to this number plus 4, so this must be 234. And this is 92, and it should equal to this number plus 2, so this must be 90. By the way, because an alpha particle is a helium nucleus, not a helium atom, it does not have electrons, so it has a positive 2e of charge. However, we usually do not write positive 2 up here in these nuclear equations. Beta decay. A beta particle is either an electron or a positron. If the decay gives off an electron, it is called a negative beta decay. When negative beta decay happens, an antineutrino is also produced. If the decay gives off a positron, it is called a positive beta decay. When positive beta decay happens, a neutrino is also produced. Neutrino means little neutral one. An antineutrino or a neutrino has very, very small rest mass, much smaller mass than even an electron. Because neutrinos are neutral and have extremely small mass, it took a long time for scientists to find evidence to prove their existence. In negative beta decay, the electron is produced from within a nucleus. What happens is that a neutron changes to a proton, but in order to conserve charge, it has to emit some negative charge, and that is the negative beta particle, an electron. Because a neutron has 1 nucleon and 0 proton, we can write 1, 0 over here. A proton has 1 nucleon, 1 proton. That means to help us balance this equation, the numbers we can put over here would be 1 minus 1, 0, 0 minus 1, negative 1. It's a good idea for us to remember this. These numbers 0, negative 1 can be very useful in helping us balance nuclear equations. Now see if you can balance this negative beta decay equation. We can put in 0, negative 1. So 14 should equal to this plus 0, so this must be 14. 6 must equal to this plus negative 1, so this must be 7 over here. In positive beta decay, the positron is also produced from within a nucleus. This time, what happens is that a proton changes to a neutron. In order to conserve charge, it has to emit some positive charge, and that is the positive beta particle, a positron. What numbers do you think we should put here to help us balance the equation? A proton has 1 nucleon, 1 proton. A neutron has 1 nucleon, 0 proton. So 1 equals to 1 plus 0, and 1 equals to 0 plus 1. So we put 0, 1 over here to help us balance the equation. Now see if you can balance this positive beta decay equation. We can put 0, 1 over here. So 12 equals to this plus 0, it must be 12 over here. 7 equals to this plus 1, so this must be 6. The last one here is the gamma decay. Do you remember what gamma ray is? Gamma rays are high-energy photons. A gamma ray photon is given off when an excited nucleus undergoes energy level transition to a lower energy state or to the ground state. Because these energy level transitions involve a nucleus, not electrons, there is a lot more energy involved. Therefore, very high energy gamma ray photons are given off. The asterisk here denotes excited state for this nucleus. A photon has no charge and no rest mass. It's just energy. So the gamma decay does not affect the numbers here in the nuclear equation. One can say 0, 0 fit here for the gamma particle. Now let's compare these three types of particles. An alpha particle is a nucleus. It has positive 2e of charge. It has mass, much more mass than the beta particles. A beta particle is an electron or a positron. It has a charge of 1e. It has mass, although it is much lighter than an alpha particle. A gamma ray is very high energy photon with no charge and no rest mass. Which of those do you think is the most penetrating through material? The gamma ray, of course. It turns out that a hand can block alpha particles, but not the beta. And a concrete block can block beta, but a gamma ray can penetrate the concrete to some depth before being absorbed.